In this chapter, we're going to talk about how to choose the right certificate for your needs. And we're going to begin with a discussion of certificate authorities, or CAs for short. Certificate authorities are entities that issue digital certificates. CAs certify the ownership of a public key. Remember, that's what an SSL certificate does. It certifies the ownership of a public key. So CAs are going to perform that for us. The way it works is that we're going to go to one of these CAs. We'll provide them with some information about ourselves or our organization. Most importantly, we're going to tell them what URL we're going to be using, and then we're going to give them a public key. And then sometimes we'll have to pay a fee as well. They'll then, in turn, validate that that public key and that information all matches up and looks good and give us back a certificate certifying the ownership of that public key. It's similar to notarizing an identity. In the real world, you might go to a notary and ask them to notarize a document you were signing. You might bring your identification so they can see you are who you say you are, and they can say that they did see you sign the document. It's a similar process here. The idea is that we have a trusted third party that's going to vouch for this public key. The browsers are going to keep a list of the certificate authorities, either their own list or they'll borrow one from the operating system. A browser is going to trust those certificate authorities, and since a CA has certified that a particular URL owns a public key, a browser knows that it can trust the public key. Now we should pause for a moment here and just talk about what kind of trust the browser actually has. What has been certified is that a public key belongs to a particular URL. That's it. It's not saying anything about the entity behind that URL. We don't know if they're good people or bad people. We don't know if their business is doing well or if they're about to go bankrupt. All we know is this public key is a legit key for that URL. We haven't been given a fake one by someone who might be trying to trick us, right? Somehow intervene in the process of connecting to this URL. We know the public key we're getting from whatever website we're connecting to belongs to that website. We'll come back to this point again a little later. So certificate authorities are actually based off of a couple of different levels. The first level is root certificate authorities. There are very few of those. Those are the ones that have the sort of ultimate authority of the internet to decide who's trustworthy and who's not. But because there's only a few of those, they can't handle the huge volume of certificates that are required. So we need more CAs. Now we don't want to just add more root certificate authorities and bestow this sort of top level trust on them. So what we do is we create intermediate certificate authorities. The root CAs are able to delegate their work and their trust to those intermediate CAs. So a root CA vouches for an intermediate CA. An intermediate CA vouches for a URL's public key. A browser that trusts the root CA then can trust the public key. We end up with a chain of trust. We don't have to know about every single intermediate CA. We just have to know that it's a trusted intermediate CA that's been trusted by the root. There are many certificate authorities that are out there. Most of them require a fee in exchange for their service, in the same way that a notary might require a small fee to notarize a document for you. So at the time that I'm recording this, these are the most popular certificate authorities based on the number of certificates that they issue. You'll notice that on the right-hand side, Symantec actually owns several different ones. So you can actually buy a Symantec certificate or a VeriSign certificate, GeoTrust. They're all coming from the same place, but it's worth noting that they all have different prices and different options and things like that. So they still function like different companies. They've just all been acquired by the Symantec brand. Up until 2016, if you wanted to get an SSL certificate, these were the companies that you had to go to in order to get one. Now we have another option, which is Let's Encrypt. We'll talk about that in the next movie. In the last movie, we talked about some of the paid certificate authorities you can use in order to get an SSL certificate. It's also possible to get free certificates now using Let's Encrypt. And we all like free, so let's talk about what that is. Let's Encrypt is a free certificate authority. You can access it at let'sencrypt.org. Of course, that's HTTPS, because of course it's got to be an encrypted site. It's a nonprofit organization that's promoting the adoption of HTTPS. They would like everyone on the web to be using HTTPS all the time. And to help make that happen, they're providing free certificates that are easy to set up. Now, these work exactly like the certificates you get from paid authorities, but there are a couple of small differences. One, you can't get all the same kinds of certificates that you could at all the paid authorities. And we'll talk about different certificate types in a moment. But we have limited choice among the types that we have, and the certificates from Let's Encrypt are valid for 90 days, but they're auto-renewable. At the paid certificate authorities, you typically get one that's good for like a year, maybe more, and then it just sits there on your server, and every year you go back and you renew it and you update it again. These certificates are good for a shorter period, but they make it easy for them to auto-renew. It's almost automatic. So they're good for a very short period of time, but they auto-renew. They recommend you auto-renew every 60 days so that you don't actually run out of time. So 6 times a year, your certificate will need to auto-renew. Let's go to their website and take a look. So this is let'sencrypt.org. Their website may change over their time as they update it, but hopefully there will still be a nice big Get Started button. And we'll come back to that later and find out how we can actually install certificates using Let's Encrypt. But they try to make it as easy as possible. There's a couple of other things to note here. First of all, it is a nonprofit, so you can donate to them. There's also documentation to help you out. And then I want to come over here to About Us, where they have some statistics. Let's take a look at those because they show some of the points that I've been making. This is a chart on the growth of Let's Encrypt. And you can really see how Let's Encrypt has taken off since the project first started in 2016. So in just a very short amount of time, it has just skyrocketed, and it looks like it's going to continue. And if we look at the percentage of web pages loaded by Firefox using HTTPS, we can also see the enormous growth there. So the blue line is showing all users. The green, orange, and red lines are breaking it down by USA, Germany, and Japan. So look at the blue line there and notice that it's gone from 30% and it's climbing up there and it's at 70% and still climbing. So we're getting there very quickly. And a lot of that growth has happened in 2016 as a result of Let's Encrypt. If you scroll down just a bit more, you can get an idea for how many certificates Let's Encrypt is issuing per day. There's a couple of big spikes in there, but overall you can see that they're issuing pretty steadily over 500,000 certificates every single day. So Let's Encrypt offers a great opportunity for us to get free certificates that are easy to set up. We'll come back and talk about how to set them up in the next chapter. We've learned about certificate authorities, and we've seen that there are paid certificates and free certificates. There's another kind of certificate that I at least want to mention to you, which is self-signed certificates. Self-signed certificates are certificates that have not been approved by a certificate authority. Instead, they've been signed by you. You're the one who vouches for them, not a certificate authority. That still allows you to perform encryption with them because they still have a public key attached. But what they lack is third-party trust. We don't have that organization out on the internet who has vouched for the fact that this public key belongs to this entity. So if you try to visit a website that uses a self-signed certificate, the browser is going to display a security alert because it doesn't trust it. So why in the world would you ever want to use a certificate that isn't trusted by a third party? Well, they're useful when you have two systems that want to communicate with each other that already trust each other. Let's say, for example, that I work at a big company and I have an office that's in San Francisco and another one in New York. And I control all the servers. So I know what the public keys are on both of these servers. I can vouch for them. I know that they're legit, and I don't need a third party to tell me that. Those two servers should be able to communicate and use encryption and use all the kind of mechanisms like TLS that we have to communicate back and forth without having to go to a third party in order to trust them. It's a rare case that you'll ever need them, but they are an option for you. If you're a web developer, 99.9% of the time you want to stay away from self-signed certificates and use one of the paid or free certificates from a certificate authority. There are rare cases where you might want to have a self-signed certificate while you're setting things up and trying it out, but most of the time, if you're going to have users coming to your website, you want them to have that third-party trust. In this movie, we will discuss the different types of certificates. All certificates perform the same basic function. They certify that a public key belongs to a website or organization. But there are differences in how they are issued that are important to understand. The first difference is the domain scope. The most common type of certificate is a single domain certificate. This would be a certificate where a public key is certified to belong to a single website. For example, www.coolsite.com. Notice that that URL includes the subdomain in front of it, www. Our certificate and our public key would be certified only for that single domain, including the subdomain. If we wanted it to apply to multiple subdomains, for example, library.coolsite.com or members.coolsite.com, well, then we would need to get a wildcard certificate. It's exactly the same, it just allows us to have different subdomains. We'd have one certificate and one public key, and we could use them for coolsite.com, library.coolsite.com, members.coolsite.com, and so on. There's a third variation on this, which is the multi-domain certificate. Again, it's the same kind of certificate, but we're allowed to have one public key and one certificate that's able to be used for multiple domains. It'd be used for coolsite.com, greatsite.org, and coolsite.net. There's a fourth variation on this, which is the UCC or SAN certificate. That stands for Unified Communication Certificate or Subject Alternative Name. Those are similar to multi-domain certificates, but they're primarily used for Microsoft Exchange and Office communication environments. Paid certificate authorities may offer some or all of these different domain scopes as options when you purchase, and you'll just want to purchase the one that's right for you. The second difference is the level of validation. The three validation levels are domain validation, organization validation, and extended validation. All three would use the same public key and the same type of encryption. What is different is the effort that the certificate authority makes to validate the ownership of that public key. Simply put, they charge more money to do more work in validating that an owner is who they say they are. Domain validation is the most common, and they're only certifying that the public key and the website domain name are related. Typically, the way this is done is an automatic email is issued to the website owner that's listed in the Whois database. That's the database of people when they register a domain name. So it'll send it to whoever says that they own this website, and if they can receive that email and respond to it, then that's proof of ownership enough. They may also ask you to post a data file on the website, because if you own the website, you should be able to put a small data file up there that they can then see publicly. Those are just very simple ways that we make sure that a URL belongs to a public key. Organization validation has the same kind of validation as domain validation, but it also confirms the authenticity of the organization by checking business databases for articles of incorporation and confirming the physical address of the business. That's it. It just checks those databases and makes sure that this entity does actually exist. It's not made up. Extended validation does the same type of validation as organization validation, but it takes one additional step to validate the organization. An actual human person contacts the business at a published phone number. They may even speak to several people there, but just having an actual person check to make sure that someone answers the phone there and this business is who it says it is. And that's all it does. It just checks to make sure that someone answers the phone and says, yes, this is the right business. Now, of these three levels, domain validation is going to be the cheapest, the fastest, and the easiest. Extended validation is going to be the most expensive. Now, of course, certificate authorities want to sell you that most expensive option. They'd like you to pick extended validation. So they're going to make it sound like they're doing a whole lot of extra validation and that it's so valuable to have extended validation. But at the same time, they want to keep their costs low and validate it as cheaply as possible. So beware their sales pitch. The original idea was that these validation levels are supposed to imply that more validation means that the site is more trustworthy. But what you're paying for is really just basic online research and a few phone calls to verify that the business exists. It says nothing about whether a business is reputable or whether it's in good financial shape, just simply that it exists. One of the perks of having extended validation, though, is that many browsers will display it differently when you go to a site that has extended validation. They'll put a nice big green bar at the top, and they might even put the company's name instead of the URL. That can make them look much more trustworthy. Certificate authorities love that. But the problem is that hackers can buy extended validation certificates too. They realize that these make websites look more trustworthy than they actually are. And for that reason, a lot of the browser makers are beginning to stop doing that. They're going to stop showing these big trustworthy banners for extended validation certificates. And the value of extended validation certificates is going to decline. So in short, if your goal is to encrypt your communications or to prevent browsers from complaining to your users, just pick simple domain validation. If your goal is to provide the highest reassurance to your customers possible, go ahead and still pick the extended validation. It does still convey that additional trust right now. If the additional cost of getting extended validation makes you pause, then you probably don't need it.